Hey everybody. So now we're going to do like the most advanced kinds of, okay, I don't know what happened. Then we're going to do the most advanced kind of probability questions. So up until now, you're like, oh my gosh, I mostly get this. I got this. And then as we go into this piece where it's like super advanced probability questions, um, just keep in mind that this is really advanced, this section, and these concepts versus before, if you got those, that's really good. Okay, so oh, hang on. Yep, OPN. Okay. So find the probability of getting 4 aces when 5 cards are drawn from an ordinary deck. Okay, keep in mind order doesn't matter here. Because if you have a deck, if you have order doesn't matter, because if you have 5 cards in your hand, it doesn't matter where those 4 aces are. So you have 5 cards in your hand. 5, these 4, 4 need to be aces. And then this one is anything else in the deck. All right, and so probability is what you want over the total. And so our total is we're choosing out of 52 cards, we're going to choose 5. And the reason it's combination is because the order doesn't matter. Then these first 4 cards, I want all 4 aces. And 50, so then I have 1 card left. And so 52 minus 4 is 48. And so out of those 48 cards, it doesn't matter what I pick, I just need 1 card left. I want you to notice a couple of things. 4 plus 1 is 5. 48 plus 4 is 52. And so we still did what we want, what we're looking for, over what our total was. All right, so in my calculator, I'm going to do 4 combination 4, get 1. Then I'm going to do 48 combination 1, I get 48. Then I'm going to do 52 combination 5, get a really big number. And so my answer is going to be 48 over 2,598,960. Let's see if that reduces at all. No. Okay, and so this is, I'm sure it does, but and so that's my answer. It'll reduce, so I'm not that worried about it. All right, so let's do another one. Okay, so remember, probability is what we want over the total. So store 6 entertainment magazines and 8 news magazines on the counter. If 2 customers purchase a magazine, find the probability that 1 of each was purchased. All right, so we have 6 and 8, and the total number of magazines is 14. The order doesn't matter if somebody purchases a news and then an entertainment, or an entertainment and then a news, so that's why we're going to do combination. And we're picking 2 of them. And so for the first one, there's 6 choices, and we're picking one of them. Oop, that's a C. I put an E for entertainment. And then for the news, there's 8 choices, and we just want one of them. All right, so notice 1 and 1 is 2, and then 8 and 6 is 14. So I'm going to do 6 combination 1, which is 6, I'm going to do 8 combination 1, which is 8. I'm going to do 14 combination 2 is 91. 91. So I get 48 over 91. Okay, and that's good enough. Perfect. Right, this guy, I find this super confusing, but it's really applicable. All right, so a box has 24, excuse me, transistors. 3 are defective, and your 4 are sold at random. So 4 are sold. Find the probability that exactly 2 are defective. So these 2 guys are defective, and these guys are normal. All right, remember, probability is total over want. So the total is 24. And so if we're picking up 4, it doesn't matter what order those defective ones are. And so for the first 2, they're defective, and we're getting 2 of them. So we have 3 defectives to choose from, and we're picking 2. And then for these guys, they're normal. And so 24 minus the 3 defective ones is 21. And then we need 2 of those. All right, so the defective ones are there. The normal ones are there. And then keep in mind that 3 plus 21 is 24. 2 plus 2 is 4. All right, so 3, choose 2. Combination 2 is 3. 21, combination 2 is 210. 24, combination 4, 10, 6, 2, 6. So I get 630 over this 10, 6, 2, 6. And I'm sure it can be reduced. It reduces to 15 over 253. But that's 30 is fine. All right, let's do no defects. 1, 2, 3, 4. And so none of these have defects. All right, our denominator is still going to be the same. And so there's 24 total, and we're choosing 4. And then none of these are defective. They're all totally normal. And so of the normal ones, there's 21 normal ones, and we're choosing 4. 6 is still going to be at the bottom. And then 21, choose 4, 5, 9, 8, 5. Right, this is fine. I'm just telling you that it reduces to 285 over 506. All right, let's do all defects. We're getting 4 of them. All right, and okay, these are defective. Oh, and then this is normal. Okay, and so probability, we're picking 4 of them. There's 24 to choose from. Okay, and so there's only 3 defective, so it's 3 defective, and we want all 3. And then this last one is going to be 21, and we just need one more. Okay, 3 plus 21 is 24. 3 plus 1 is 4. So I'm going to do 3 combination 3 in the calculator. I get 1. 21 combination 1 in the calculator. 21. And then we have that big number. 10,026. So 21 divided by 10,0626. It simplifies to 1 over 506. So the chances of getting all the defective ones out of the box of 24 and is 1 over 506. All right, then we have this at least one is defective. That's those magic words, at least one. So we're going to do the exact opposite, which is none of them are defective. Okay? And we got, for none defective, 5985. 5985. Okay, that is for none defective. Okay, so we're going to do 1 minus the none defective, 1 minus, and so you need to make sure that when you do this, that there's parentheses. 1 minus, parentheses, 5985 divided by just make sure it's in parentheses, and so we get 221 over 506 when it's reduced, and so we could have actually done 1 minus this 285, would have been also fine. All right, and so that's at least one is defective, which is about 44%. All right, in a Pennsylvania state lottery, a person selects a 3-digit number. Repetitions are permitted. If the winning number is selected, find the probability you have all 3 digits the same. So that happens here. All right, and so for a probability, we want what we're looking for over the total possibilities. And so the total possibilities are, so 10, 10, 10. So you get 10 over 1,000. And so that reduces to 1 over 100. You have a 1 over 100 chance of it repeating, of getting one of those numbers as the winning numbers. All right, don't overthink this particular problem. There's 8 married couples. Okay, 1 man and 1 woman are selected at random to play. Find the probability it's a married couple that is selected. So probability is what you want over the total. And so the total is, there's 8 married couples. So, and we're going to pretend married as men and women. So there's 64 because it's 8 men times 8 women. And then there's 8 married couples. So it's 1/8 chance that they would be married to each other. All right, so that's advanced probability. And we finished up this chapter. We're going to do a couple sections in the next chapter for this unit. All right, I'll talk to you later. Bye.